Good morning, my mathematics lovers. How are you doing? So in our last video, we did say that x squared plus 3x minus 1 over x plus 1, it equals x plus 2 minus 3 over x plus 1. And how did we do that? We used long division and the remainders theorem to arrive at this answer. And this answer, having broken down this expression into this, we were able to carry out our integral. For the benefit of those who did not follow the last video or the new members of the group, of this page rather, we want to just go over that long division process again. Just wait. So this is the long division process again. We're using x plus 1 to divide x squared plus 3x minus 1. So x goes into x squared. We have x. You use the x to multiply the whole of this expression. X into x times x will give us x squared. X times plus 1 will give us plus 1x. And then we said you will have to subtract this expression from this. And to do that, we said you have to be very, very careful about the sign. So x squared minus x squared will just cancel out, while 3x plus minus 1x will give us 3x minus 1x, because plus times minus gives you a minus. So 3x minus 1x will give us 2x. And then you bring down this other part of it, which is minus 1. Of course, x can still go into this expression. X into 2x, you get plus 2. And then 2 times the whole of this expression, you get 2x plus 2. Again, you subtract this expression from the one on top. So again, 2x minus 2x will go away, leaving us with minus 1 plus minus 2. We perform the same operation, subtracting this from this. Remember the minus signs. So 2x will go with 2x, and we are left with minus 1 plus minus 2. Plus minus will give us a minus. So we'll have minus 1 minus 2, which gives us minus 3. And at this point, the whole of this expression will become our quotient. This will become our divisor, and this will be the remainder. So we went ahead to use the remainder theorem. So this is the remainder theorem, that f of x equals q of x plus r of x all over d of x. So we have basically gotten our q of x, r of x, d of x from the long division that we carried out. Our q of x was what again? So we said our q of x was x plus 2, r of x was minus 3, and d of x was x plus 1. So coming here now, this is our q of x, x plus 2, plus our r of x, remember, it was minus 3, all over d of x was x plus 1. So this gives us x plus 2 plus and minus, so that will change to minus 3 all over x plus 1. So this was the answer we got the last time. Now, I want us to combine these two to see if we will get back the original function. Let us try and combine these two to see if we'll get the original function. That is the aim of this video. So watch as we're going to do it. So here we have a fraction, and here we have a linear expression, s plus 2. If we want to combine them, the first thing we want to do is to convert this to a fraction. And we say x plus 2 all over 1. Yes, that converts it to a fraction. You can go and check our previous video. Minus 3 all over x plus 1. So how do we add these two fractions? Of course, I'm sure you still remember from our previous video. You take the common factors, which are 1 and x plus 1. So that will just give us 1 times x plus 1. and then you cross multiply the original fractions. So what does that give to us? Let me elongate this a little. You have x plus 2 times x plus 1. Then 1 times minus 3 will just give you minus 3. So all I would do is to expand the upper part of it. So x times x, there you get x squared. X times 1, get plus x. Then 2 times x, you get plus 2x. And then 2 times 1, you get plus 2. And the remaining thing there is minus 3. All over x plus 1. So we didn't do any magic here. Basically, this x, you used to multiply x, you got x squared. X, you used to multiply 1, you get 1x. Then 2 times x, you get 2x. And then 2 times 1, you get plus 2. So that's what we did there. Don't get confused. All right, now we collect like terms on top here, and then we see what we get. So x squared term will have only x squared with just 1. Then x plus 2x gives us what? 3x. Then plus 2 minus 3 gives us minus 1 all over x plus 1. And guys, that's basically where we started from. We started from x squared plus 3x minus 1 all over x plus 1. So you can see that the remainders theorem, it worked perfectly. This was where we started from. Using long division, we were able to get our q of x to be x plus 2. We got our arrow of x to be minus 3. We got our d of x to be x plus 1. And we got this expression. Now we combine this expression, and here we are getting back where we started from. So you can see math is constant practice. I decided to bring this example again for us to see that this thing, with repetition, you'll be able to master these steps, and these steps are going to help you as you go higher in mathematics.
So to be successful in maths, start from the basics. You cannot simplify expressions and you are learning simultaneous equations. Don't learn simultaneous equation if you have not learned simplifying expressions, collection of like terms, solving simple linear equations. It's not possible. You cannot be good in simultaneous equation if you have not known these topics I have mentioned. So that is why I'm saying the best way to learn maths is to start with the words.
All right, if you got a concept, can you try this? Just try this and work it out. Show all your steps, and please drop your comments, show workings in the comment section, and then we'll review it together. They say practice makes perfect, and that's what we want to do in these our tutorial classes. Just give this a try. It's very, very simple. I actually gave it to my son to try, and he tried it. He got it. So let's work it together and see how it goes. Thank you for watching. Please share this video, comment on this video, follow my page if you are not doing so. If you are already following my page, there is no need for you to leave. If you are following this page, you will have something to benefit, if not every other day, but at least once in a while. You will have something to benefit either from the knowledge or whatever. So please keep following this page. We're here to learn while having fun, and our goal in this page is to make learning as easy as possible, to remove all those complexities from learning. Doing so, I believe that all of us will be able to push away that phobia we all have for mathematics and learning generally. Thank you very much. Bye for now.